Okay, hello everyone. I'm here with Mike Huemer. He is like a professor or something and has written some books. Um, who are you? For those who don't know.
Yeah, just I'm just some guy on the internet, you know. Um, wait, okay, wait. Let me see. Let me check one of my books for who I am. Oh, it looks like I'm a professor of philosophy at the University of Colorado, where I've taught since the last millennium. I'm the author of more than 80 articles in epistemology, metaphysics, ethics, and political philosophy, in addition to approximately 10 other amazing books that you should immediately buy.
Wow. Wait, how long have you been publishing for around?
How long I've been what?
Like publishing for in philosophy
Um,
journals?
I don't know, around 98. I had
So that's like 4 articles a year. Yeah.
yeah, I had 2 papers in graduate school or something like that.
Okay.
Yeah, and I graduated
Um,
in 1998.
nice.
And it gets
Yeah.
easier later on. Like if you're well known, then people start inviting you to write articles, and then you don't even have to submit them for review. Just write the invited thing. The only disadvantage is that then you have to write about what the other person wanted you to write about.
Ugh. Tragic. So okay, so what we were going to discuss was infinite, the puzzles of the infinite. So
Yeah,
so one puzzle of the infinite that I
and
think
also
I
why
don't,
everyone should buy this book.
yeah, um, that I don't think you discuss in your book, but I read it a while ago, so I might be wrong. And I know this is a great sin. One should read your books. It's sort of like the Bible, they should engage in daily Michael Huemer reading.
Yeah,
If they
yeah,
get to a puzzling passage, they should meditate over it, and ask the Lord for guidance in interpreting it. Um,
yeah, yeah. And also
uh,
just buy more of my books because they'll
right,
have more.
right, yeah. Buy different editions of your books to sort of
Yeah,
read
yeah,
it from different angles, yeah, in
yeah,
case one of the translations is wrong. Um,
yeah, yeah. Although they're all in English.
yeah, and they're all infallible. Um, uh,
Yeah,
no,
only when
no,
I'm speaking ex cathedra.
yeah, no scribal errors. So one puzzle that I don't think you discuss. So let's imagine that you have an infinite number of galaxies, and each galaxy has one well-off person and like a billion badly off people. Uh, is the universe bad? Just for the record, this is obviously only step one in the puzzle. It doesn't sound like a puzzle yet.
Yeah, so it sounds like the answer is yes.
Okay,
Sounds like it's
and then
bad.
suppose that you have an infinite number of galaxies, each of which have like a billion well-off people and just one miserable person. Is
Yeah,
this
yeah,
world good?
yeah, that sounds good.
Yeah. So the puzzle is that uh, it seems like you could rearrange the first world to become the second one just by moving people around. And so then if you accept both of these judgments, you get this strange result that just like moving people around dramatically improves the quality of the world. And the way to see that you could rearrange this, well, so let's just do it with smaller numbers. So let's say right now, let's give all the people a label. So let's say in world one right now, in the good world, there's 1W, 2W, 3W, 4W, and 5W, which means one well-off person, two well-off person, sorry, one
Yeah, yeah,
well-off person one, well-off person two, well-off person three, ... And then 1M, which is the first miserable guy.
yeah, yeah,
And then there are an infinite number of these people. But this means that for every natural number, there's a paired both happy person and miserable person. But you could just have 1M, 2M, 3M, 4M, and 5M go to Galaxy 1 and have only 1W stay in Galaxy 1, then 6M, 7M, 8M, 9M, and 10M go to Galaxy 2, only
yeah,
2W stay in Galaxy 2, and so on. So it seems like you can rearrange the first world to get the second world without making anyone worse off. So,
yeah.
yeah.
Yeah, no, of course you can't actually physically rearrange them because it would take forever. um, and you have to move people at unlimited speed. But the larger point is if there are two sets that are both countably infinite, or there are two sets that both have Aleph null members, then you can have a one-to-one function that goes from one set onto pairs of members of the other set, or vice versa. So you can match set A 1 to 2 onto set B, or vice versa, or 1 to a million, right? And like another way of thinking of that is, well, infinity times a million is infinity. Infinity times a billion is still infinity. So in some sense, it's still the same number. Yeah, I'm not really sure what the answer to this is, or I don't know. I don't think there is a standard answer to this. Like intuitively, you might say, well, the spatial arrangement of the people shouldn't matter, right? So actually, in your first version of the story, we should have said, well, there's the same number of happy people as miserable people, and the same in the second version. So yeah, I guess maybe this is the standard analysis for people who follow Cantor. It's the same number. In both cases, you have the same number of happy and miserable people, so they're both neutral, or maybe it's both undefined. Maybe there is no value.
Yeah, I mean, I think you'd want to say they're both like their goodness in both cases. They don't have a precise goodness or badness, right?
Yeah.
Like you wouldn't just want to say they're exactly neutral, because you can improve them and then they're still incomparable with the other.
Yeah. Right. Yeah. I think the standard view would be it's not neutral. Rather, it's completely indeterminate. Right. There's no answer to whether it's overall good or bad. There's no total value of the universe.
Yeah.
Right. Because if somebody asked you, what's the sum of, let's say, all of the negative numbers and all the positive numbers, you'd be like, okay, in standard mathematics, there is no sum. That's what they would say.
Yeah.
So is it positive or negative, right? So because asking whether the universe is overall good or bad is like asking whether the sum is positive or negative, the sum of everyone's utilities.
Yeah, right. So I agree with that. So just to be clear from this, so earlier you were suggesting that the world where each galaxy had one well-off person and a bunch of badly off people, that one's bad, and the other one where it is mostly every galaxy has a bunch of well-off people and one badly off people is good. You would say that judgment isn't true. You think they're both incomparable, because just like our intuitions get weird with infinity.
I'm really not sure what you should say about that. So, sorry.
Maybe you should write a book about it.
Yeah. That wasn't one of the things I considered. Now, like most of the paradoxes, I try to resolve by saying that the scenario is impossible. But that scenario with an infinite number like Aleph null people is not impossible, even according to my theory, right? Like my view is more restrictive than some people, but it would allow there to be Aleph null happy people and Aleph null miserable people.
Yeah.
So I would like to be able to say it's impossible, but I don't really have a basis for that.
Yeah. So I mean, one way to go. Well, so one way to go that I've been thinking about that like Daniel Rubio and various others have written about involves revising the assumptions of standard mathematics, which whenever you're in a philosophical conundrum, you should do, where the idea is that the way to think about infinite sizes is in terms of surreal numbers. And I'm not super wedded to surreal numbers, as I don't understand them. But something in the vicinity where surreal numbers, they have all these nice properties where if you like add a surreal number add 5 to a surreal number or something, you get a bigger number. And so the idea would just be that you think the right way of modeling them is not bijection, where you can have two infinite sets where there's a bijection between them, you can pair them 1-to-1, but one of them is in fact bigger than the other. And we're going to have to accept this if you think that a whole is necessarily bigger than its parts.
Yeah. But I mean,
and then just to explain the resolution to the puzzle, the idea would be that if you have an infinite number of galaxies that each have, say, 5 well-off people and one badly off person, you couldn't actually transform it into the other world just by moving the people around. there isn't a possible world that has all the same people, but that has every galaxy filled mostly with badly off people, because there are more well-off people. And the idea is that it sort of seems like you could transform, like you could have a world with the same people, but we shouldn't really trust our modal intuitions about infinite numbers of people, because this is all super weird.
But what? So, I mean, what about, like, you were trying to describe how you could move them around, right? So, like, why doesn't that work? What would happen that would stop you from doing that?
Well, I mean, I thought, so you thought that physically moving, so the idea is that you can do it so there are lots of things where you can do them any particular number of times, and it seems like you could do them indefinitely, but you can't have them be done indefinitely, right? So the Grim Reaper paradox is an example of that. It's like, what would stop you from just keeping adding Reapers forever? The answer is, well, you can only add a finite number of Reapers. So in this case, well, for any particular number, like for any, you can move the first 5 people to the galaxy and the next 5 people. You can't actually do this an infinite number of times.
Yeah. Well,
and I agree, this is not a very satisfying solution, but the alternatives are also very bad. And I join you in being confused about it.
Like, that's what I said about the Hilbert's Hotel story, right? That, like, you can't actually move all of the people in the hotel. So, the Hilbert's Hotel, like, there's the infinite number of rooms and they're all filled with an infinite number of guests, but, like, you can still fit new people in because, or, like, you could fit an infinite number of new guests in because you just tell each person who's in room N to go to room 2N or whatever. Okay. And I pointed out that, well, this would take forever. So, like, each one of the infinitely new guests would eventually get a room, but it would literally take forever to finish. Okay, but I mean, what I think is relevant is not really whether you could finish the physical process of moving the people in the different galaxies, right? What's relevant is that you could just imagine another possible world in which the galaxies have just already been in the way that you're imagining rearranging them.
Yeah, but I would deny that you could imagine another possible world like that. And the reason I would deny that is that the idea would be that if in the first world, like, you have omega galaxies and each of them have 5 well-off people, well, then you have 5 times omega people. And then if you have 5 times omega people, then you can't actually arrange the galaxies so that every galaxy has mostly miserable people if there are more well-off people.
This sounds false. Well,
look, all the views here sound false. The question is, which view sounds the least false?
Well, somebody could just, like, you can give a description, right? So, okay, so there are these galaxies, call them G1, G2, G3, and so on, right? And in one possible world, G1 contains these people, call them, W1, W2, up to W5, plus, M1. Okay, and then G2 contains these people, whatever, W6 through 10 and M2. Okay, so that's one description. It sounds like a possible world. And then, just give another description of the possible world, right? Where instead G1 has M1 through M5 and W1. No, right? So, like, you can see how the description goes, right? And
so the thought would be that you could do that any finite number of times, but you couldn't complete the process of making all the people just because there are more of the second category of people. And so even though there's only one, so it might seem weird that there's more of the second category of people, even though in each case there's just one person who's either happy or miserable for each natural number. But the idea is that even if you have one for each natural number, that doesn't fix the size. You can have one, like, you can have people labeled 1R, 2R, 3R, 4R, and 5R, and people labeled 1B, 2B, 3B, and 4B, and 5B, ... in both cases going to infinity, and yet there can be more of one of the first than the second. This may seem weird, but it seems less weird when you consider the following case. So imagine we have 2 scenarios. You start with an infinite number of people. And in one case, you get rid of every person who's each with who's labeled with a natural number. In the first case, you get rid of every person whose natural number is not a multiple of 4. So you get rid of every person except 4, 8, 12, 16, and so on. And in the second case, you multiply everyone's natural number by 4. You can think of these as their welfare level or something. It doesn't really matter for the setup. Even though in both cases there's just 1% for every natural number, there's some intuitive sense where when you get rid of the infinite number of people, then you have fewer people, based on the principle that a whole is bigger than just part of it.
Right. Yeah. So I mean, that is to say, it's intuitive that a proper subset of a set is smaller than it. If A is a proper subset of B, then A is smaller than B. Okay, and that's sort of like at the heart of Galileo's paradox, right? Where he was wondering if there are more natural numbers than there are perfect squares, or vice versa, right? And so the perfect squares are a small subset of the natural numbers. As a matter of fact, as you get larger and larger numbers, the proportion, the proportion of numbers that are perfect squares gets lower and lower, right? So the perfect squares are 10 of the first 100 numbers, so 10%. But if you go to the first 10,000 numbers, then it's like only 1%. So in some sense, the perfect squares are 0% of the natural numbers, but every natural number has a square. So okay, all right. But so and the standard Cantorian response to this is just ignore part of it. So just ignore the intuition that a set is larger than a proper subset of itself. Okay, but let's say we agree that, I don't know, in some intuitive sense, a set is larger than a proper subset of itself. But that doesn't help you with comparing two sets where neither of them is a proper subset of the other one, where they're just two disjoint sets that both have.
No, I wasn't suggesting that it would help you with that. My point was that even if you have two sets where each that are just like a person labeled with each natural number, it's intuitive. It may sound weird at first to say that one of the sets is bigger than the other, but when you think about it in more detail, then it can stop seeming so weird. And so if you accept that a set is bigger than a subset of the set, that's a hard sentence to say. Then you get the result that there are cases where, even if two sets both have a value that can be paired with every natural number, one can be bigger than the other.
I mean, let me put it this way: if a set is going to be larger than another one, you might think there should be some criterion that by which you could say that it was larger, right? And okay, so there's the Cantorian condition, is there a one-to-one function? Okay, and then there's this, proper subset criterion. But then you're suggesting, well, there's another time when there's no criterion by which the one is bigger. It just inherently is bigger as a brute fact.
Why? I don't think it's just a brute fact. There are way in surreal math, there are ways of calculating the size of different infinities, where it has something to do in lots of cases with the density of something. So this turns out the result that, for example, there are more odd numbers than prime numbers, even though both are infinite. And now that does seem a little bit weird, but here's an intuition pump. Let's imagine we're in Hilbert's hotel and they're either going to kill everyone in an odd number room or in a prime number room. I'd be much happier if they killed everyone in the prime number room than in the odd number room.
Yeah. Well, so every individual would have a higher probability of surviving. So there's sort of a decision theory argument.
Yeah, I can describe it.
You mentioned this, you look at the density or something. So this involves there being a natural arrangement. So in the case of the numbers, there's a natural arrangement of the numbers. Just arrange them by, the less than relation or whatever. 1, 2, 3, 4. Okay. And so then you can talk about the density. And then in your example with the people in the different galaxies, well, okay, so there could be a greater density of happy people because, just you take a given volume of space, it contains more happy people than unhappy people. But that doesn't change the fact that, there could be the same people in a different arrangement, the same people with same utilities, but with a different spatial arrangement.
Well, I would just deny that that there could be all. And to be clear, I'm not too wedded to this solution. I have maybe like 30% credence in it or something,
Yeah.
Because I think all the views are bad. But, putting my surreal hat on, I'd say that that you couldn't actually have all the same people where every galaxy has mostly blue-shirted people. And the reason is simply that what determines the structure of possible worlds is it isn't correspondence. So even if A and B, there's a bijection between them, that doesn't mean that you could construct a possible world where there's some like natural spatial arrangement where things are arranged however the correspondence is. Maybe it would be helpful to describe another similar case that I think is like that I think is relevant to the infinite ethics. That is sort of a similar puzzle to the ones in infinite ethics. Just because the reason I agree the things I'm saying are very weird, but the worry is that every view is really weird, and so maybe this is the least bad option. So let me just discuss kind of two like puzzles that this nicely resolves that other theories seem to have to say bad things about. So one of them is that suppose we think correctly that the universe is infinitely large. It seems like on standard views, this means that our credences in almost everything will turn up undefined, right? Because let's consider my credence in me being hit by a supernova 1 second from now. Well, the same number of people are hit with my experiences are hit by supernovas. Well, I guess maybe you could get out of this by thinking there are only a finite number of people. But okay, but assume there are an infinite number of people. And you shouldn't think that for reasons we'll maybe discuss later. So if there are an infinite number of people, then imagine that there are the same number of people with my experiences who are hit by supernovas as there are who are not hit by supernovas. And so then the question is, on what grounds do I say I'm probably not going to be hit by a supernova? Especially because, like, if you just move the planets around with their accompanying nearby supernova, you could rearrange the galaxies so that every galaxy has a billion people who will be hit by supernovas and just one person who won't be hit by a supernova.
Yeah. Well, I mean, one would be tempted to say, well, there's a physical probability. Like if you take a random person before you know what's going to happen to them, there's some objective chance of them being hit, which is going to be determined by the laws of nature or something like that. And so like it's not determined by counting the total number of people that it happened to, maybe, right? It's determined by the physical properties of the system.
Okay, well, I have a few worries about that. One of this is that I think objective probabilities are propaganda from big frequentism. With the most granular fact is that take a comparable case. Suppose a coin's flipped. You can say, look, the objective probability of the coin is 1.5. And so 1/2 chance, even if there are an infinite number of coin flippers, that the coin comes up heads. But I don't actually know what. So my coins being flipped under the exact conditions under which I flip my coin, which is the most specific version of the evidence. Those coins have an objective probability of coming up heads of either 0 or 1, right? Either given the way in which I flip the coin and so on, the conditions in the environment, either it'll come up heads or it will come up tails. So it's not clear on what grounds I would conclude that it'll probably come up heads. or sorry, on what grounds I would conclude that I should be indifferent between heads and tails. Because I don't, it's not like there's some actual event that's genuinely random. It's that there's an event that either is guaranteed to come up heads or tails, but then I just don't know which one. So I think it, so I'm random epistemically because of my ignorance.
Yeah. Yeah. So yeah, when we say there's a 50% chance of it coming up heads, like maybe that's just because you don't know the exact starting conditions of the coin when you flip it. And if you knew that, then it would be determined how it's going to come out. But because you don't know the exact initial conditions or exactly how hard you're hitting it with your thumb, you apply the principle of indifference. So there's sort of like a range of initial conditions that's compatible with your information, and then you give a uniform probability distribution over that range of possible initial conditions, and then in about half of that range, the coin would be determined to come up heads, and about half the range would be determined to come up tails. Okay, but so that's like a more
but in this case it seems like maybe it would be undefined because in this case it seems like maybe it would be undefined because well, so we have to be careful when applying the principle of indifference to an infinite number of options. I guess maybe this works in the coin flip case because you can just say, look, like imagine you just it's like the objective probability. You shouldn't try to take that into account with infinite numbers of people, and then the subjective probability is just 1/2, and that's what you would assign probabilities as if there was just one person. I guess going back to the supernova case, I mean, in what sense is the objective probability low? Like in what sense is there a low objective probability of you being hit by a supernova? Because it's not like most people aren't hit by supernovas. It's that there are the same number of people who are hit by supernovas and not hit by supernovas, namely infinite in both cases.
Well, wait, so sorry, I'm just being distracted by sort of like the details of the scenario where you get hit by the supernova because like the only star nearby is the sun and it's 93 million miles away. So even if it somehow went nova, it couldn't hit you within 8 minutes or so. Okay.
Well, I think maybe there. Well, so first of all, I mean, I could fill in more details of the scenario where maybe there are an infinite number of worlds where the nearby star that's the sun, we sort of think it's not the kind of star to go supernova, but we're wrong. And I think there are other nearby stars that are such that if they went supernova, they'd kill us maybe, but like we think they won't go supernova, but like
okay. Well, I was imagining like maybe there could be a freak event in which the Earth turns into a star and then it burns you up.
Yeah, or like a gamma ray burst or something.
But anyway, okay. In order for you to be hit by a supernova within some time period, the physical environment, in your in the light cone, sort of like going back whatever that amount of time, has to be one of a certain number of arrangements. Okay, now you don't have perfect knowledge of what is actually in your backward light cone, but you could like assign probabilities to like different ways that the physical environment could be, and most of the ways that it could be would lead to you not being hit, right? And it's only like you have a very low probability for there just happening to be a star or for the Earth turning into a star, just sort of like based upon your assumptions about what you think is the current state of the Earth and your immediate environment.
But my worry is that it seems like that's parasitic on some sort of assumption about the relative rarity of those things, right? So let's imagine that like let's not talk about supernovas. Let's just say like massive gamma ray bursts, and I think gamma ray bursts are actually undetectable. That the only way we would know is if basically we were hit by them.
Yeah, when it happens because it travels at the speed of light.
Yeah.
You know it when it hits you.
Yeah. Gamma ray bursts. Hard to define, but you know them when they hit you. So you get hit by a gamma ray burst, and it's unclear on what grounds you'd say there's a low probability that you're hit by a gamma ray burst. Like, it seems like the reason why we think it's unlikely is that we're reasoning most planets don't get hit by gamma ray bursts, but in an infinite world, that's false. It's undefined, the share of planets. And you could rearrange the planets so that almost everyone is hit by a gamma ray burst without assuming you
can't physically rearrange it, but you can enumerate them in a certain order.
Yeah, there's maybe you could rearrange it. It sort of depends on your views on infinity. But anyway, there's an alternative possible world with all the same people on all the same planets, where every galaxy is filled almost exclusively with people who are about to get wrecked by gamma ray bursts.
Yeah. Well, I mean, the actual reason why we don't think this is going to happen is, human history has been going for a while, and there were no recorded cases where that happened. And we can say that even though we don't know if there are infinitely many people or whatever.
But of the people who make that judgment and who say, so probably we won't be hit by gamma ray bursts, versus people who say, but I have no idea the probabilities, like the same number of people who have survived up until this point get hit by gamma ray bursts as don't get hit by gamma ray bursts. Right, so it would be like, imagine that you knew that the setup of the world was that every second, imagine first case. You knew every day, 90% of surviving planets got hit by gamma ray bursts that nuked them. You should think probably, even if you've survived up until this point, if you know that's the setup, 90% chance you'll get hit by a gamma ray burst tomorrow. And now imagine if we say an infinite number of planets get hit by a gamma ray burst every day, so that there's no fact of the matter about the probability that you'll get hit by a gamma ray burst. Okay, then the question...
There's no fact about the frequency.
Sorry, yeah, no fact about the frequency. It seems like even if you've survived for a long time, it seems like maybe you should have an undefined probability distribution over the various gamma ray bursts.
Yeah. I mean, so one thing to think about is, well, what is the standard view? Like the people who accept Cantor's views about infinity, whatever. What would a typical mathematician say about this?
They accept propaganda from Big Cantor.
What are we supposed to say about? But then also we could think, well, I don't know, maybe the standard view is wrong. So maybe, okay. So one thing is that, maybe you'd say, well, there's a probability, but it's not based on frequency because the frequency is undefined. Standard view says the frequency is undefined, so you can't use that to base your probability judgments. Okay, but another thought is, well, yeah, so maybe it is sort of the frequency, but it's like you have to have a natural ordering, and maybe a natural ordering would be like just taking contiguous spatiotemporal regions and larger and larger contiguous spatiotemporal regions, and you're not allowed to have disconnected, picking things in different parts of space.
But I mean that result implies that if you have two worlds with all the same people with all the same properties, your credence in having some property should be different between the two worlds, which is false. You shouldn't think that. If A is true, if and only if B, your credence in A should equal your credence in B.
I agree with that principle, but I'm not sure I saw the connection there.
Oh, well, the connection is, so let's imagine you have two worlds where in one world, the two worlds have all the same people. In one world, they're arranged so that every galaxy has 5 red-shirted people and 1 blue-shirted person.
Yeah.
And the other galaxy, they're arranged so that every galaxy has 5 blue-shirted people and 1 red-shirted person. On this picture, in the first world, you should think 5-6 chance you have a red shirt. Second one, you should think 5-6 chance you have a blue shirt. But they have all the same people. And so you have a red shirt in the first world, if and only if you have a red shirt in the second world. But your credence in having a red shirt in the first world should differ from your credence in having a red shirt in the second world.
Yeah. Let's see. Yeah, I'm thinking, I don't. Does it make a difference that you couldn't actually have this information? Right? Because you couldn't be reliably informed that that you were in one of these two worlds and that they would have literally the same people. So, like, you could imagine just knowing that the universe is either one in which every galaxy has 5 red shirts and 1 blue shirt person, or the reverse. But there wouldn't be any way of verifying that exactly the same people would exist, because you can't perceive a person's hexaity. So, there's nothing that detects that. But that might be just an irrelevant.
Yeah, that seems real, because like you could imagine them knowing it, even if like imagine God informs them of it or something.
Yeah, I mean,
or maybe all possible people exist or something. I don't know.
Yeah. I mean, this would be a suggestion where even God couldn't know that, but this might just be a digression that isn't helpful.
Yeah, right. I mean, even if you get around this argument, it just seems obvious that your credence should be the same between those two worlds if they have the same people. Well, I guess maybe that you'd say you could never know, but like, I don't know. Even if you couldn't know, it seems like for any world, that has mostly galaxies full of mostly red-shirted people, you should think you could have a world with exactly these same people where each galaxy has mostly blue-shirted people. You should think, in this world, I probably have a red shirt, and in that world, I probably have a blue shirt.
Yeah. Yeah. So, I don't know, but I mean, it seems like, it seems like you should expect to not be hit by a gamma ray burst in the next minute.
I agree.
I'm going to take that as a fixed point. So, how should we assign the probability so that we get the correct answer?
Yeah. Well, one way of doing it is the surreal solution. And yes, it's weird, but sometimes you got to accept some weird things to avoid 1 billion paradoxes.
But I don't know how surreal numbers work anyway, but I don't know how you're going to, even if you accept this sort of like mathematical framework, I don't know how you're supposed to get the probability. Like, how do you know? So, you might want to say, oh, no, there's actually more people who don't get hit by the gamma rays than who do. But how do you know it's not the other way around?
Well, in this case, the way you'd know it is a pretty good heuristic for determining this is you just look at, in an expanding sphere of space, what the frequency of people with various probability with different probabilities of having different properties, right? So if in every particular as this expanded sphere of space expands, it's mostly non-gamma ray burst people, you think probably you won't be hit by a gamma ray burst. And now remember, the objection to that was, look, okay, but that implies that if you just rearrange people, your credences should change. And the surreal response to that is you couldn't rearrange people so that your credences would change. There isn't a possible world with all the same people, just arranged differently so that each has.
Well, no, I mean, I don't see what blocks somebody from hypothesizing that there's actually 10 times as many people who do get hit by the gamma ray bursts as who don't. It's just that the way they happen to be arranged is that the ones who get hit by the gamma ray burst just happen to be farther from each other than the ones who don't get hit. But there's more of them anyway.
The idea is that the idea is that if you have an infinite number of galaxies, each of which have 5, say each galaxy has one guy who gets hit with a gamma ray burst and 1,000 who don't get hit by the gamma ray burst. The way you do the surreal probabilities here is you just multiply the number of galaxies by the number of people per galaxy. So you have 1,000 gamma ray burst people 1,000 times omega people who get hit by the gamma ray burst, and just omega people who do get hit by the gamma ray burst.
Well, yeah, I'm not sure why that's the okay. So we let's say we agree that there's more natural numbers than there are prime numbers, and then so then there are these people who are getting hit by gamma ray bursts, and we could label them. We could have them be G1, G2, G3, and so on, and there would be one for each natural number, and then we could have these other people who are not getting hit, and then we could label them G1, 2, 3, 5, G7, G11, G13, okay, with all the prime numbers. And then we could say, okay, so you see there's more people being hit by the gamma ray burst. So then you have to say, oh, well, there's something privileged about this spatiotemporal arrangement.
Well, the idea is, I mean, the thing is, you're thinking of size in terms of bijection, right? So you're saying, look, we could pair these people in this way where we line them up with the primes. But the way to think about size on the surreal view is not to buy into propaganda from Big Cantor, but it's to think about size in a different way, where you think of size as just in a way more similar to how you do with natural numbers, where it's just like you have infinite of something, you multiply them. So even if there's a bijection,
sorry, just to clarify, I'm not assuming that I'm not assuming that the size of a set can be determined just in Cantor's way, right? I'm just saying that so it's it's just a fact that there is a bijection between the natural numbers and the prime numbers. Yeah. Whether or not that means that they're the same size, I'm not assuming that means they're the same size.
Yeah. Well, so the idea is that if you have an infinite number of galaxies and they all have mostly red-shirted people, then the way you determine the number of red-shirted people is you multiply the number of galaxies by the number of red-shirted people per galaxy. And so then there are more red-shirted people than blue-shirted people.
I mean, I guess part of my, another way of phrasing my puzzlement is, well, what's special about galaxies? So a galaxy, so that's a particular way of dividing up space-time into, galaxy regions. But there's another partition of space-time where, call them schmalaxies, or each schmalaxy, and it's going to be a disconnected space-time region. But anyway, each schmalaxy contains 1,000 people who do get hit by gamma rays for everyone who doesn't. So now you have to tell me what is the privileged way of dividing up space-time?
Yeah, I agree. This is a worry. I think that what you'd want to say is that, just like with the principle of indifference, you're just going to have to privilege some particular thing that you do indifference over. You can't just be indifferent about any two things, because being indifferent about sizes of the lines contradicts being indifferent about the sizes of a square. In a similar way, you're just going to have a privileged way of counting them up, where it's hard to think about exactly how to do it in more complicated cases, but I'm confident that the privileged way of divvying this up like it doesn't look, it's not like super gerrymandered where it involves this like giant, like very weird carving up where it's like you snake through like and just like pick out people from 10 galaxies and then one from the near, and then like you're like keep divvying them up in this weird way. Yeah. I agree that it's weird that we have to have a privileged way of divvying them up, but like every view here is super weird. The question is just what's the least weird view. And if this is the only way to avoid the conclusion that it's false that I probably won't be hit by a gamma ray 1 second from now, without giving up on other super plausible principles, I'm more confident that I probably won't be hit by a gamma ray than I am about like infinite partitions. So
I'm highly confident that it's probable that you will not be. I'm almost certain of that. Well, I mean, what I tried to say earlier was, do you have some sort of background belief about what the distribution is of physical properties in this space-time around you? And there's sort of like, there's a configuration space, right? There's a space of ways that could be configured, and it's only in a small portion of that, like only a small volume of the configuration space results in you being hit by the gamma rays. Okay. Now, I guess, you might ask, well, what's my justification for believing that? I don't know. But, like, that's clearly true, right?
That a small portion of configuration space involves being hit.
So the configuration space is just sort of like the space of possible ways that a system could be configured, right? Like, so with dimensions for all the properties that the particles could have and so on, right? So it's like a, super high dimensional space, right? So, but, in that space, the actual configuration of a physical system is at a particular point. Right? And then like, changing different aspects of how it's configured is moving through the space, right? Okay. So in only a small portion of the volume of the configuration space, is there stuff that would cause you to be hit by a gamma ray burst? If you see what I mean.
Yeah, but I'm doubtful that this is the right way of doing it. Right. So here's an analogy. Let's imagine you have an infinite number of red-shirted. Okay, consider 2 worlds. In world 1, there are an infinite number of red-shirted people and an infinite number of blue-shirted people. And in world 2, all the same red-shirted people exist, and there are an infinite number of blue-shirted people, but just half of the previous blue-shirted people. Well, I shouldn't say half, an undefined share. Like an infinite number of the blue-shirted people instead have green shirts. Now, 2/3 of the possible ways of being configured have blue or green shirts. And so now you should think that it's more probable that you have a blue or green shirt in this case than that you had a blue shirt in the first case, even though you have a blue or green shirt in this case, if and only if you had a blue shirt in the first case.
Right. I mean, I think this might be getting at that you have to have like a privileged way of characterizing the configuration space, right? Like you have to have a privileged characterization of what the dimensions are. And, but like that's inevitable if you're going to have objective answers to probability questions. But I don't know, I don't know if that answers your objection there. Mm-hmm.
I'm not sure. I mean, it seems like it sounded, and maybe I'm misunderstanding, but it sounded like what you were saying is, look, there are a lot more states that it could be in where you're not hit by gamma rays than where you are. And my point is that if you have an infinite number of things, you can just break them up into a bunch of different states, but it doesn't seem like they should change the probability that you're in the conjunction of those states.
So I was confused by that.
Sorry. So the idea is, okay, let's imagine. So you have a world where you have an infinite number of blue-shirted people and an infinite number of red-shirted people. And then you just like do a bunch of different processes to the red shirted people, or sorry, to the blue shirted people. So you paint some of them green, you paint an infinite number of them green, and then you put gears on the head of an infinite number of them. You do I don't know why that was the go-to example. You do a bunch of different things for each of them. Now the configuration state, most of the distinct states they can be in, there are an infinite number of distinct states that people can be in. And for most of those states, sorry, not there are an infinite number of states. There are a bunch of different states. For each of them, there are an infinite number of people in those states. And for most of those states, yeah, sorry.
So, I don't know if this is important, but what I should have said was sort of like, there's the portion. So there's, the configuration space, all the possible physical configurations of your environment, but then you have some knowledge about it, which, okay, just assume that you know something. Okay, so you want to look at the portion of the configuration space that's compatible with your knowledge. And then, when you learn new things and you have to update it and you have to eliminate parts of it. Okay, and then, this space, it has continuum many points. Okay, but, there are still volumes in the space that could be bigger or smaller. Right, and okay, and like this space itself is unchangeable because it's like a set of all possibilities. What could change is only your knowledge of it. So you just like come to know that you're in over here rather than over here or something. Right. So that like there isn't anything that you can do to actually change how many possible configurations there are, right? And I thought that might be relevant because I thought you might be sort of like trying to imagine changing the
I'll have to think more about it. I'm not sure if I'm quite getting the picture, but maybe I'll have to give it more thought. Okay, other infinite puzzle to discuss. Well, maybe this isn't so much an infinite. Well, not really an infinite puzzle so much as it's related to infinity. Yeah. So when we last discussed, we were talking about. So I had my argument for theism, which is that every possible person exists. Or sorry, from the fact that you exist, you get very strong evidence that every possible person exists. Because if every possible person exists, then it's likely that you would exist. Well, if not, like suppose only like 5 people exist, it's very unlikely that you'd be one of the 5 people. And so then if you have like some big infinity worth of people, then the best explanation of why they would all exist would be that God exists. And you disagreed that you said, okay, maybe this does give you evidence that every possible person exists, but maybe there just aren't that many possible people, right? So maybe there are only finite possible people, or maybe only out of null possible people. So we argued about the number of possible people. But I think there is just a sort of straightforward argument from this sort of anthropic reasoning for thinking that there are a lot of people, right? So first of all, what it seems matters isn't the number of possible, the proportion of possible people that exist on a theory, but the number of total people, right? So here's an example. Suppose you have 2 theories. Theory 1 is that necessitarianism is true. So every possible person, so the only things that actually happen, those are the only possible things. And the necessitarian says, look, my theory, it gets so much confirmation from the fact that you exist. If on my theory, every possible person exists. So it's very likely that you in particular would come to exist. Well, in contrast, on alternative theories, only a very small share of possible people would come to exist. I don't think we should think, the necessitarian theory gets massively boosted in probability from explaining your existence because it means every possible person exists. Because even though every possible person exists, it's unlikely that I would be one of the possible people that exist. And so
That's-
in this case, similarly, you'd say like if they're only out, like it's more likely I'd be one of the Beth 2 people that exist than that I'd be one of the Aleph null people that exist, so to speak. And the way to see this probabilistically is that, so are you familiar with Elga's argument for thirding in Sleeping Beauty?
I know I've read it, so
Okay.
I think
So
I am.
yeah, the
I
idea
think
is
I agreed with it. Yeah,
yeah, I agreed with it as well.
1/3 was the right answer.
So Elga's argument, and I'll apply it to numbers of people rather than days. So let's imagine a coin's flipped. If it comes up heads, one person gets created. If it comes up tails, 2 people get created.
Yeah.
Elga says tails is twice as likely as heads, and its argument is the probability that you'd be the first guy to be created and the coin came up heads equals the probability that you'd be the first guy to get created and the coin came up tails. And the probability that you'd be the first guy to get created and the coin came up tails equals the probability that you'd be the first guy to get created, the second guy to get created, and the coin comes up tails. And then that means that 2 of the possible scenarios are where the coin comes up tails. And the reason to think that the odds of tails, of you being the first person in heads equal the odds of you being the first person in tails, is that, like, imagine finding out you were the first person. Well, both heads and tails predict you'd exist, so you should be indifferent between them. So that's Elga's argument. So my claim is that you can give a similar argument for thinking that there's a bigger cardinality of infinity number of people, where the idea is, so let's imagine there are either Aleph null people or Beth 1 people. Well, the probability I'd be one of the first Aleph null people, if they're Aleph, the probability that I'd be one of the first Aleph null people if there are Aleph null people equals the probability that I'd be one of the first Aleph null people if there are Beth 1 people, right? Because in both cases, if you know that you're one of the first Aleph null people, both of them predict your existence.
Okay, wait. But I'm confused by the statement that you're one of the first Aleph null people. Like, what does that mean? Like, is there some privileged ordering of people?
Well, so it doesn't have to be like an exact numbering. The idea is like, if you just like imagine assigning some real number to all the people, right? So imagine assigning, so imagine if there are Aleph null people, you assign a natural number to all the people. And if there are Beth 1 people, you assign a real number to all the people.
Well, then suppose for a continuum many people. Isn't Beth 1 too big for the real numbers?
Beth 1 is continuum many. It's Beth 2 that's bigger than continuum many.
Oh, is that right? I thought, okay.
Yeah, Beth 0 is the same as Aleph null. Beth 1 is the power set of Aleph null, and then Beth 2 is the power set of Aleph null. Okay. Beth 2 is also Wikipedia helpfully informs us that it's the number of check something compactification functions, which I thought was really helpful for getting my head around the concept. So like, oh, it's that number.
Yeah. Yeah, I'm familiar with that. Okay. Sorry. Okay, sorry, interrupted you for a second.
So the idea is, so let's imagine you give them all a number, and then you find out that you're assigned a natural number. I claim that you're one of the people assigned a natural number. I claim that you should be indifferent because, but between the two hypotheses, because both of them predict. Both of them predict that the people who are assigned the natural numbers would come to exist, with equal probability.
I mean, if every person, I mean,
well, actually, sorry. Here's a better way of doing the scenario. Let's imagine that God first creates Aleph null people, and then he'll create Beth 1 people if he can, right? If there are more possible people to be created, more souls to be
actualized.
So you get created. You don't know your birth rank. You don't know that you're one of the first Aleph null people. And then you learn, surprise, surprise, you're one of the first Aleph null people. I claim now you should be indifferent between the two hypotheses because both of them predict the first Aleph null people would be created. They just lead to differing predictions about whether the other people would be created.
Yeah. Okay. I don't know. So, I mean, like, this is the, other way of thinking about it. Suppose you're told that God has assigned a number to every person, and you're not sure. Okay, you assigned a real number to every person, and then God tells you, okay, and your number is 50. Now, okay, what's the probability of that happening? Okay, the probability of that happening is 0, right? Yeah, everybody has some real number out of all the real numbers, and then yours happened to be a natural number. Okay, so that's probability 0 then. Okay, now, so alternately, somebody tells you, well, God has assigned a number, but I'm not sure if he assigned a real number to everyone or if he assigned a natural number to everyone. Then you hear that your number is 50. Now, what should you think? You should think, okay, he assigned a natural number to everyone. The probability that it was a real number, from all the real numbers is 0 now, right? And then, so then, it seemed like in your scenario, we find out that your number was 2 or whatever. It seems like then you should conclude that there are not continuum many people, right? Because if there was, then the probability of your being one of the natural number ones would be 0.
Yeah, but I think that the probability that you'd exist is infinity times higher if there are infinitely more people. And the way to see this is just like think intuitively about the case where you create Aleph null people, you learn you're one of the first Aleph null. God creates Aleph null people and then creates Beth one or continuum many as the kids like to call it. Continuum many. Continuum many additional people if he can. Seems like in that scenario, you shouldn't think with absolute certainty that he won't create continuum many people.
Well, so it sounds like you're entertaining a probability distribution under which it would have been uncertain that you're one of the possible people, and then there's a higher probability that you're possible if there are Beth one possible people, right? But I'm thinking, no, the a priori probability that I'm a possible person is 100%. And I'm just uncertain about how many other possible people there are. So I would be possible no matter what. So if there's only Aleph null possible people, I would be one of them.
Yeah.
No.
Well,
why is that? Why would that be? I don't know. Just from understanding, just from being aware of myself, I could just intuitively see that it's possible for me to exist, and that's necessary. And there couldn't have been an arrangement of the world where that wasn't possible.
But this, you could make the same argument. Look, from being aware of myself, I know that I exist, but nonetheless, you existing can serve to confirm some hypothesis. And I agree that it's weird, but I think that it becomes less weird when you take into account your uncertainty, where you do the kind of Adam Elga style reasoning, where you say, look, because I'm just as likely to be one of the first Aleph null people if whether or not there are Beth one people that get created, or whether first you create Aleph null and then Beth one, or continuum many, or whether you just create Aleph null. In both cases, there's an equal probability that I'd be one of the first Aleph null people. Like if I know that I'm one of the first Aleph null people, I shouldn't get a massive update. And then once you do that, it's like, well, probably I'm one of the people who would only exist if there are Beth one people, and so it provides evidence that there are Beth one people. I'm sure. Yeah. Sorry. Good.
Yeah, this is super right. So, so, well, I don't know. Just just I don't know, and something that you mentioned before, like there's the fact that I'm certain right now that I exist, but the fact that I actually exist. But that doesn't mean that that is probability one for me now, but that doesn't mean that I can't serve as evidence for things, right? But sort of like the way of understanding that is, although I know for certain that I exist, I can imagine a counterfactual situation in which I wouldn't exist, and then I can sort of like assign probabilities, maybe based on what I think I understand about how the world works, to my having come into existence. Um, but I can't imagine possibility where it's not even possible that I exist. I mean, like that, like that, not only seems wrong to me, but I don't even understand that, right? What I mean? So,
Well, I don't know. I mean, you could here's a possible way reality could be. Just like out of nothing, nothing comes necessarily. Like I could imagine that being the case. And so then, and you, on this picture, things would have to have an explanation. There's no necessary foundation. And so necessarily, I wouldn't come to exist. Like I could imagine this. I don't think this is ideally conceivable, but I could sort of in a shallow sense imagine it. Right. And I claim that you get good evidence against the way you get evidence against this hypothesis is that, well, it's incompatible with the data that you exist, and that you possibly exist.
well, okay, wait. I mean, I can imagine the universe being in a state such that it's nomologically impossible for me to come into existence. But I can't imagine a situation in which it would have been metaphysically impossible for me to have existed, right?
I don't know. Seems sort of like it's weird that there's something rather than nothing. I could imagine it being the case that just there's necessarily nothing. Now I know that to be false because I exist, and I'm not intending to claim that it's contingent that that's necessarily false or anything. But my point is just that you reject that theory. Let's see. How do I state the point?
Well, I mean, you might be thinking, "Oh, I'm only rejecting it empirically. I have the empirical evidence I exist, so then I know it's not the case that it's impossible for things to exist." But I don't actually think it's empirical. I think my experience enables me to understand the proposition that I exist or the Earth exists or whatever. Enables me to understand that. But I think the understanding is sufficient to know that it's possible, right? So if you just understand, just understand.
Sorry,
yeah. If you just understand, like what it means for the Earth to exist or something, then you intuitively see that it's necessary, that it's possible for the Earth to exist.
Yeah. So here's another case. So let's imagine you're a necessitarian. So you think that the actual world is necessary. It seems coherent to me to say, look, on necessitarianism, it's low, even though on necessitarianism it's necessary that I exist, it's still low probability in that it's unlikely that the thing that would happen to be necessary, let's imagine you have a picture of necessitarianism on which there aren't that many people. It's unlikely that the thing that would happen to be necessary is that I would exist rather than something else.
Right. Well, I find the view that's being considered confusing. So I have to just sort of try to think how I would think if I held that.
I agree. Necessitarianism is very crazy.
So
I'm glad people have formulated it because it makes a useful example to illustrate why saying something is necessary is not an explanation. Where you're like, okay, we're gambling in Vegas, and I get a
Well,
bunch of royal flushes in a row, and I say, oh, it's necessary. That's my explanation.
yeah, I mean, I'm inclined to think that the problem is that there are certain things are necessary that obviously are not. And so then there just obviously is an alternate possible world in which you don't get the royal flushers or whatever. Um, and yeah, and you're conceiving of that possibility and attributing probabilities to it and whatever. But if it's a case where, well, yeah, you might think, well, it just has to be conceivable. It doesn't really have to be possible. If you're going to assign probabilities to a proposition, it's got to be sort of conceivable, but doesn't have to be metaphysically possible, maybe, right? But the thing where, like, it's not even metaphysically possible that I have existed, I think is inconceivable. It's like not only metaphysically impossible, but it's like I can't even really understand that, right? But like there's a lot of views in philosophy that are like that I feel like I can't even get what you're thinking.
Yeah, just to be clear, I agree that necessitarianism is crazy in part because it says obviously possible things are impossible, but it does seem weird to think that like the necessitarian theory that there are 7 people. Suppose I come to exist, and you have 2 theories. One theory says that there are like a billion people contingently, and the other theory is a necessitarian theory that says that there are like 7 people. It seems weird to think that the necessitarian theory gets a massive probability boost because it makes it like, it predicts with certainty that I would exist, because the point is that even if it predicts it with certainty, it's like it's unlikely that I would exist necessarily rather than someone else. I don't know, maybe you just don't have the intuition, but I have the intuition that this is a further problem for necessitarianism, that necessitarianism shouldn't, like, even if, like, you should think necessitarianism is improbable on modal grounds, but you shouldn't think it gets like a massive probabilistic boost from saying, oh, your existence is probability 1. So necessitarianism, it confirms all the data. It predicts with absolute certainty that 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 like all your experiences would be exactly as they in fact are.
Right. Well, yeah. Just thinking about like what is the proper way to think about the probabilities when somebody has a thesis like that, and like maybe the proper way is, well, we consider these other propositions that other things had been necessary that person is saying are impossible, right? So they could have necessarily been 100 people or whatever. But like what makes that legitimate? Because they're saying the thing that you're entertaining is impossible, and then why can't they say so it has probability 0? And then like the thought might be, well, at least it's conceivable. So even if it's so whatever, even though I'm entertaining that there had been more possible people and you're saying that that's impossible, it's epistemically possible, even if it's metaphysically impossible. So then like maybe that makes it legitimate to assign non-zero probabilities, right? But then I want to say, the scenario where somebody says, what if I had not been a possible person? I'm going to say, well, that's not even epistemically possible. It's not even conceivable or whatever. Like it doesn't have even the barest kind of possibility that something could have, so that it would make sense to assign probabilities to it, or not to assign non-zero probabilities to it.
Yeah, I didn't. I didn't. That doesn't seem right. And in particular, so suppose that there are Beth 1 people. It's not, the idea is not that it, like, on that picture, it would in fact be impossible that you'd exist if there were only Aleph null people. For most of the people that exist, if there are in fact Beth 1 people, then for most people that exist, necessarily their existence would be impossible if there were only Aleph null possible people. And so upon finding that you exist, maybe you should think, well, probably I'm one of the Beth 1 people, because there are more of those guys who exist. And then probably I'm one of the ones who only possibly exists under the Beth 1 people theory.
Right. So under the Beth 1 people theory, like conditional on that theory, my probability of existing if there were only Aleph null possible people would be 0.
Yeah.
But okay. But then what?
Well, so the idea would be that from the fact that you exist, you think, look, probably I'm one of the Beth 1 people for the Elga reason. And so probably
no.
I only exist possibly on one hypothesis. And so probably the hypothesis that makes me exist is true.
But that's no, but I mean, I think you're assuming that there could be Beth 1 possible people. But if there aren't, then there couldn't be.
I don't think you're assuming. Well, you're assuming like for epistemic purposes that there could. I don't know this. Yeah, this it gets a bit confusing.
But wait. So there's like, all right. So I don't know. There's two things. There's the fact that I'm a possible person, and then there's the fact that I'm an actually alive person. Okay, so my claim is the probability that I'm a possible person on either theory should be 1. And then the probability that I'm an actually alive person will be different. I don't know.
Well, okay, so it gets tricky to explain exactly where this goes wrong. But the idea is that it's... So on either theory, you know that you're in fact a possible person. But it's not the case that both theories predict that both theories are such that if they're true, then the other theory predicts that you're a possible person, right? So if the Beth 1 theory is true, that there are Beth 1 possible and actual people, then only that theory makes it likely that you're a possible person. Because
yeah, right.
maybe we should switch topics. It's not. Yeah, it's
Yeah. Well, we have limited time. We got a lot of paradoxes of the infinite that we haven't talked about.
Yeah. So one other paradox, and maybe we talked about this last time. So there's the Grim Reaper paradox. Well, do you want to explain what your solution? we've discussed these like paradoxes that your view doesn't solve. Should we discuss like what your view is and how it maybe solves some of the paradoxes?
Yeah, we could do that. Well,
or maybe people should have to buy your book to find out your view.
Buy the book.
You should just make vague sort of statements about the view, about how it clears up all these puzzles. Even Democrats come up to you and they say that you have is a wonderful view, and they're so impressed.
A lot of people are saying they've never heard such an amazing view before. It's tremendous. Okay, well,
I can't believe how unfairly you've been treated with the view. Even Democrats say that.
Yeah, that's right. Yeah, everybody's saying it's totally bogus criticisms. So, like, I mean, here's this sort of puzzle that I thought about for a while. Okay, so first you think about Zeno's paradox. So for an object to go from point A to point B, it has to first go half the distance, then it has to go half the remaining distance, and half the remaining distance, whatever. Okay, and then somebody gives an argument that says, well, you cannot complete an infinite series, so therefore the object cannot reach point B. Okay, but it seems like that's false because things do move. Okay, so then you want to say, oh, so maybe well, what could possibly be wrong with the argument? It looks like what has to be wrong with it is the claim that you can't complete an infinite series. So it looks like you can complete an infinite series. Okay. And then, here's another example, Thomson's lamp. Thomson's lamp is a lamp that it starts out off, and then after half a minute, it gets switched on, and then after a quarter minute, it gets switched off again. Then after an eighth of a minute, it's back on, whatever. Okay, so it gets switched an infinite number of times within 1 minute. And so then at the end of 1 minute, is it on or off? Okay, and then, it's a big puzzle. And then you're tempted to say, so that lamp is impossible. It looks like the reason why it's impossible is that you can't complete an infinite series. Okay, so now it looks like the answer to the first paradox is the negation of the answer to the second paradox, right? So like in Zeno's paradox, you want to say, oh, well, I guess we can complete infinite series. And then with Thomson's lamp, you want to say, well, we cannot complete an infinite series. So then you have a puzzle about, okay, well, so when can you complete an infinite series? Right? So that's, okay. And then like a broader question is just like, what kinds of infinity are impossible? And then, like a related thing that I wondered about was, like physicists and cosmologists are very worried about the infinities in a black hole. So like the black hole is a singularity, which means that it has infinite energy density, which means it has infinite space-time curvature. And this is considered a problem in physics. Like that's why there are theories of quantum gravity that are trying to eliminate these infinities. And like it's commonly said that physics breaks down because these quantities go infinite. Okay. But nobody has a problem with certain other infinities. So they don't have any problem with the idea that space-time is infinitely extended. So like the total volume of space is infinity. No one has a problem with that. No one thinks that physics breaks down because of that, or that we need new theories to make it be finite, right?
The me of a year ago thought that when we last talked about this, but I no longer think that.
Oh, okay. Okay, good. But okay, yeah. So, like what kinds of infinity are problematic and which ones are not? All right. So then, I thought about it. Well, it just seems like the problematic infinities are infinite intensive magnitudes. And the infinities that are okay are, there could be infinite cardinalities. So there could be a set that has infinitely many members. And it looks like there could be infinite extensive magnitudes. And so like length is an extensive magnitude, or volume, or duration of time. Those are all extensive. So it looks like, time could be infinite and space could be infinitely large or whatever. Then, okay. So the theory, and what's an intensive magnitude? So roughly the difference between intensive and extensive is that the extensive magnitudes are additive over the parts of a thing. So if you have a region of space, like the size of the left half plus the size of the right half is the size of the whole. Okay, intensive magnitudes are not like that. So if you have, your coffee is a certain temperature, the temperature of the left half plus the temperature of the right half does not equal the temperature of the whole. Okay. So the theory is you can't have infinite intensive magnitudes, but you can have infinite extension, you can have infinite cardinalities, right? And there's a further explanation of why that is, right? And the explanation involves that, there are no infinite numbers in the sense of, a number that's larger than every real number, or a number that's larger than every natural number, right? There's natural numbers and the real numbers, they go all the way up. There's not another number past them that's bigger than all of them. And in order to explain what it means to have an infinite intensive magnitude, you have to say that there's a number larger than all of the finite numbers. But to explain infinite extension, you do not have to say that, or an infinitely numerous set, right? So to explain what an infinite set is, you could just say, well, an infinite set is just one such that it has subsets that are arbitrarily large. And so, but each of these subsets, when I say this, it has arbitrarily large subsets, I mean, like there's a subset with any natural number of elements that you want. It just goes up forever. Okay, but I don't have to then say that there's a number that's larger than all the natural numbers. So, okay. All right, so there's a good theory.
Yeah.
And then okay, so what's wrong with the Thomson's lamp? And my claim, okay, so like the Zeno series is fine because there aren't any intensive magnitudes that have to be infinite. So like the velocity at which it travels, the amount of energy, and the energy density of the person who's moving or whatever object is moving, those are all finite. The only thing that's infinite is the number of steps, which is infinite cardinality, which is allowed. Okay, but then with the Thomson lamp, what happens is, well, there has to be like infinite energy density in order to switch a lab infinitely many times within a limited time period. You have to have an infinite amount of energy in a finite space-time region. So it's a region of infinite density. So it would have infinite curvature and etc. Yeah. Okay.
Yeah. So one puzzle is the sleeping, or sorry, not the Sleeping Beauty. That's a different thing. The Grim Reaper paradox. Fortunately, in the Sleeping Beauty puzzle, the Reapers don't kill. Anyways, so the Grim Reaper paradox, the idea, it's very similar to Thomson's lamp. It's that suppose you have one Reaper who will kill a guy after 30 seconds, one after 15, one after 7.5, one after 3.725, I think, or that's whatever.
Yeah, 3.75.
Yeah. Sorry, yeah, 3.75. It's very early in the morning where I am. All errors can be attributed to that. Well, it's actually 10:30, but I've been staying up very late, so it's morning, very early in relative time. So then the question is, okay, so, and imagine nothing other than a Reaper can kill the guy. Well, okay, can he be killed? Well, no particular Reaper could kill him, because any Reaper that would kill him, he'd already be killed by an earlier Reaper. But if none of the Reapers kill, any particular Reaper would have to kill him. So you get a paradox where he has to be killed by at least one Reaper, but no particular Reaper could kill him. Contradiction. What do you say about this case?
I mean, the way that I usually hear it is, the person just drops dead, like they just drop dead of nothing because they couldn't survive any length of time, because at least one Reaper would kill them. Actually, if they survived any length of time, an infinite number of Reapers would have killed them. And then, okay, and like my preferred response to this is to say that it's an impossible scenario. Now, it's a little bit harder to explain why it's impossible when it involves magic or something, because like there's no mechanism specified by which all of these Reapers could kill you, but there are structurally analogous stories, right? So, and I believe all these are from Jose Bernardetti. Okay, so and they're structurally analogous paradoxes, but where you understand physically what's going on, so it's easier to think about. Okay, so here's something analogous. There's a pile of slabs of stones. Okay, and the first slab is half a foot thick. And then on top of it, there's another slab that's a quarter foot thick. And then on top of that one, that's an eighth foot thick, etc. Okay, each slab is opaque. And then, this, just imagine the slabs look different. Like maybe the odd number ones are black, the even number ones are white, or, they've got numbers written on them or whatever. So just so they look different. Then you stand above the pile of slabs and you look down. And what do you see? Well, you don't see any slab, because every slab is occluded by the one above it. And there's an infinite series of them. Right. Okay. Each slab has an infinite number of ones above it, so that would block you from seeing it, so you can't see any of them. But you certainly can't see through the pile because they're all opaque. So what's going on? So what would you see? Right. And then, okay, so my claim is this is an impossible scenario because it requires something to have an infinite intensive magnitude, which is the attenuation coefficient of the material that the slabs are made of. Okay, so as a matter of fact, there's no material that's perfectly opaque or perfectly transparent. Like any material has some resistance to penetration by light. And so, light hits the material. It has some probability of stopping, for any given distance, and the probability of stopping goes up as the distance increases. Okay, and there's a particular formula for this, and there's a parameter in the formula known as the attenuation coefficient, something like that. And basically, that has to be set to infinity if you're going to make the thing opaque, with arbitrarily thin slices. Okay, and so, my claim is that's impossible. All right, there's a related story where there's there's a ball that wants to roll down a hill, and then there's like an impenetrable wall halfway down the hill. But then there's another impenetrable wall a quarter of the way down the hill, then another one an eighth of the way down the hill. Okay. So the ball can't go any distance down the hill, but no wall stops it, because for any wall, it would have been stopped by another wall before it got to that one. Okay. And then, and then there's a similar response to this, that it's an impossible scenario because there can't be walls that are completely impenetrable. The thinner a wall gets, the weaker it gets. So, the wall, and any wall, if the ball has some non-zero weight, any wall is going to deform some non-zero amount when the ball hits it. And so, right, so the ball is going to be at the top, and it is going to be deforming the walls. An infinite number of them, as a matter of fact, will be slightly deformed as the wall is pushing into them.
Yeah. Well, so what about what do I keep saying the Sleeping Beauty problem? The Grim Reaper paradox, but just with magic, right? So imagine that there are like an infinite number of disembodied minds, each of whom have the power to kill a disembodied mind, one after 30 seconds, one after 15, one after 7.5, one after 3.75.
And then whatever is after that, 1.875 or something. Anyway. Yeah, I mean, I'm inclined to say this is impossible. Magic is impossible. There has to be some mechanism by which they would kill a person. If you start describing the mechanisms, then it's going to require some intensive magnitude to go infinite. So some of the cases where you have an infinite magnitude are they require you to talk about information density or something, right? So this might be one where the Reapers have to they have to have an infinite amount of information storage ability or something like that. Why
would they have to have that?
Oh, so they're going to have to be able to detect arbitrarily small intervals of time, right? So, I think some of the resolutions require you to take a collection of objects and treat that as an object. So in the case with the walls, with the infinite number of walls, and somebody asks, well, what object stopped the ball? And well, the answer is like the sum of the walls is an object. That object stopped it. Right. Anyway, okay. So the set of Reapers, that might be an object, and that might be an object with an infinite amount of information. Right. And
I'm dubious of those solutions because it seems impossible for a set of walls to stop something if no particular wall stops it, right? And so here's one way to see it. Imagine that each wall it has wet paint on it, and every wall is a different color, right? So whichever wall stops it, it'll get paint of its color on it. Or imagine in the Grim Reaper case, the Reaper's not killing the guy. Instead, he's writing down a unique letter on a piece of paper. Which letter is written down on the piece of paper? Well, no particular Reaper's letter could be written because there would always be an earlier one. No particular wall of paint would get the paint on it. But for it to be stopped, some wall would have to get paint.
Well, yeah. So my claim with the walls is actually the ball is going to penetrate an infinite number of them, right? Because the walls get thinner and thinner, which means that they're more and more fragile, right? And so, there's some finite weight to the ball, so it has the force to push through all of the walls that are too thin to stop it, which will be an infinite number. But, okay.
I see. Okay.
And then the scenario with the Reapers, like, they have a letter on them or something. The
idea is there's a piece of paper, and every Reaper has a unique like symbol to write down.
Well, there's a sort of like variant paradox where there's a card that's going to have there's like this infinite series of agents, and each of them is going to write something on the card if there's nothing on it when the card gets to them, but they'll only write if someone and then like there's nothing to be on the card, right? You could, whatever, like each of the agents has a number and they write their number on it.
Right.
But and then my my take on that is, that's an impossible scenario because that card has to have infinite storage capacity, infinite information storage capacity, right? Because like the numbers have to go higher and higher, which means there you get larger and larger digit numbers, right? Which means that you're, going back,
Can the Reapers write the numbers in increasingly small font?
Right. Yeah. So, well,
so that
the
they're all the
thought
same
is,
size. Right. So it's just a piece of paper that's like this big, but the Reapers, they write it really small.
yeah, they write smaller and smaller, but that still implies that there's infinite information storage capacity of the paper, right? Because like you could because it's implying that you could store an infinite amount of information on that paper.
But I mean, aren't normal pieces of paper in theory having infinite storage capacity, given that you could write one number in one bit of it, then another number in half the space, and then for another number in a quarter of the space?
Well, yeah, you couldn't really do that, right? So like whatever mechanism you're using to record information will have limitations.
I see. Like okay, you think it's impossible?
With your writing with a pencil, then the size of the pencil limits how small the letters could be. But then you say, oh, okay, well then I get a smaller pencil. But like whatever mechanism is, it would have some limit.
Yeah. Okay. So yeah, maybe this. I don't know. I mean, it seems like the Reaper, in the case of the Reapers. Well, you were saying magic is impossible.
Yeah, actually, I'm not even sure what magic is. Like I had a blog post trying to figure out what magic means. And it might just mean something that's conceptually impossible.
Yeah, I actually many years ago I was trying after reading your blog post, I began writing a blog post called where I was trying to figure out what magic was. I didn't finish the blog post because I couldn't figure it out. But I mean, what's different from the magic of the Grim Reapers from there just being certain fundamental natural laws? Like what's the deeper, whatever the most fundamental laws are, things just have the disposition to do certain things.
Yeah.
The Reapers just have a disposition to do certain things and they might kill you.
Yeah. Well, I mean, my claim is going to be, okay, so like, the person who's proposing the scenario has to describe, okay, what would the laws be in this world or whatever. But my claim or hypothesis is any way that you describe it so that you would generate the paradox, it would require some kind of infinite intensive magnitude. So, there's some descriptive properties that give you the causal power to kill a person. And then there's this infinite number of these Reapers who each have the ability to kill this person. All right. And then they all have to somehow have access to him. And so then there's just going to be some causally efficacious property that's going to have some kind of infinite magnitude.
Well, the idea would be that, so that imagine they're all disembodied minds, and each of them have the capacity to just, when they will it, make the person go away, and they'll each will it at the assigned time.
Yeah. I mean, I think there have to be some, like there would be some like psychological laws or laws of mind stuff. And so like your state of willing would have to have some property that had the ability to impact the person, right? Like it's really hard to talk about this because I don't know I don't know how this world would work, right? But like if you think in like a more normal scenario, like somehow there's something that's going to kill a person. Well, there's got to be some minimum amount of energy that has to be expended to kill a person. And like all of these people, there are all of these Reapers who have the ability, each independently has the ability to kill this person. They've got to have an infinite store of energy. And they've all got to be able to do it within, there's a certain finite time period. And there's like an infinite number of them who all have access to that person in that time period. So it looks like there's got to be a region of infinite energy density.
Yeah.
And like I don't know, like if you imagine alternative laws of nature, an alternative world where they're just minds, and okay, I don't know, but I think you have to posit some sort of analogous property that a mind would have.
I don't know. I don't see anything wrong with the mind just not having to be a deeper mechanism than just having this brute ability to make the person go away at will.
Yeah. Well, I guess I want to say there has to be a categorical property that's the ground for the power. And and given that the person continues living on their own, like they don't just spontaneously die, nobody does anything, then it's got to be that there's sort of some minimum amount of force or whatever is the descriptive property that gives rise to the power to kill a person. There has to be some minimum amount that's required in order to end that person's existence. If there isn't any minimum that's required, then the person should just spontaneously die.
Well, the idea is that they have a disposition to keep surviving up until the point at which one of the Reapers wills that they die.
Yeah. So like maybe there's a quantity called willpower. Like, maybe like how strongly you will something.
It's a function of willpower over time, or of like how strongly you will it over time.
What?
It's a function of how much you will something divided by time.
Yeah. Like the intensity of your desire or intention for the thing to happen, and there would be an infinite density of that stuff in the unit of time, surrounding the person's planned death.
That seems kind of gerrymandered.
Yeah, I mean, well, it's like
because like they don't need to infinitely strongly will it. It's just that they have some will for it in a very small period of time, which seems possible.
Oh, but the problem is that there's an infinite number of them, right? And that gives you a kind of infinite density of something.
Yeah, I mean, my preferred solution is, I think, causal finitism is right. I think you can only have finitely long causal chains, but
yeah.
I mean, I'm not too wedded to it. I think maybe I'm holding out for like infinite theory X, which is some better theory of infinites. But I am dubious about your theory's ability to like solve puzzles like this one.
Yeah, I mean, I feel unworried about paradoxes that involve, stipulating magic or something that's like that. And I feel like, well, you know what? If it resolves problems involving like the world as we understand it, then I feel okay. And then, like I don't feel like it's important to solve the problem of what would happen in a world with like radically different laws. And I suppose partly because I'm not sure that these radically different laws are even metaphysically possible. Right.
Yeah.
And also because like I feel like, well, look, it's kind of unfair for me to have to explain how things would work in a world where like the person positing this hasn't told me the laws and stuff like that.
Yeah. What I mean, I think the scenario, maybe we have different accounts of what it means to describe the laws, but like I don't think that there needs to be some deeper mechanism than just look, they have the brute disposition to will the other guy out of existence after like 30 or 15 or 7.5 seconds. Like that seems like a full description of the laws.
Yeah. Yeah, the other thing is like, okay, so the Reapers have to be aware of the time, and they have to have infinitely precise awareness, because time intervals, like they've got to have clocks in their minds, and
well,
infinitely precise timekeeping.
Well, every particular Reaper only needs finitely precise timekeeping.
Yeah. So, but the collection of them, the collection of them constitutes an infinitely precise timekeeper with an infinite amount of information, right? Because they know the time to infinite decimal place accuracy. Anyway,
I don't know. I mean, that doesn't. I don't think that like sets of things are a thing in that kind of way. Like it seems like imagine that there's a clock that tells you what time it is down to just like what the hour is. Now imagine there's a clock that tells you down to the minute. Each of these clocks are one galaxy over. And there's a clock down to the second going on forever. Seems like that collection of clocks is possible, even though you could say, well, the collection of clocks as a whole is an infinitely precise timekeeping device with infinite intents of magnitude.
Yeah. Well, yeah, I think you can generate some paradoxes. There's some paradoxes that I don't see a way to avoid unless you just take fusions of things, right? So, yeah. Well, okay. Anyway, so I have an example of a puzzle in the book that that would occur in just like in Newtonian physics if you could have an infinite collection of objects, right? But probably too long to go into that.
Yeah. Well, so we have been going for about 2 hours, so maybe this would be a good time to wrap up. Unlike our first conversation where we talked for like 5 hours almost, and I said a lot of stupid things because I wasn't an intuitionist yet.
Yeah,
but
yes,
yeah.
Well, just remind everyone, buy my books. That's
yeah. Buy your books. Let's see. Are there any interesting questions in the chat? There are people saying things. Oh, the dude wants me to do my impersonation of you. I did an impression of you at one point. Do you want to hear it?
I mean, it sounds hilarious.
Yeah. So suppose that you have error theory, where you say nothing's wrong. Seems false. So it's like now the non-cognitivists they say that torture's wrong is neither true nor false. It's like, no, that seems true.
Yeah. I mean, just, as far as I can tell, you just sound like a smart philosopher. Just
a guy saying true things,
just being rational, and
Yeah. All right. Thanks for coming on, Mike. For people who are listening to this, you should obviously buy Mike's book. So though you should do that after becoming a paid subscriber to my Substack. That's even more important. I'd say the order, that's the most important thing to do. And then after that, if you have extra money, maybe buy his books, or maybe give to effective charities, both equally high impact.
And then after that, buy food and clothes.
Yeah. All right. Thanks for coming on. Have a good day, everyone. Bye.
All right. Laters.